Let's combine some logarithmic expressions together into a single logarithm. So whenever we're doing these, it's important that we have the exact same base on each of the logarithms to be able to combine them together. But then the next thing we always look for are, do we have any multiples sitting out in front of the logarithms? And in this case, we don't really. So let's move on to the next thing that when I'm combining these together, what I know is that I want to have a single logarithm when we get done. So it's going to be a log base 3. And then if it's positive in front of a logarithm, whatever's on the inside as I combine these together is going to go as a factor in the numerator. So the 5 goes in the numerator, multiplied by, as you can see, the 8. We have a positive in front of that log, so that's going to go up in the numerator as well. But the 2, we have a negative in front, so I know that's going to end up in our denominator. We can simplify down a little bit by saying log base 3 of 5 times 8 is going to be 40 over 2. And a little bit more simplifying down, 40 divided by 2 makes 20. So that's going to be as combined together and simplified as this is going to be able to get. All right, let's take a look at another one here, a little bit more complicated in that we have 4 logarithms, but kind of the same process. These are all common logarithms, so log base 10s. As I put these together, let's just be careful that the 3 positive in front, so it goes in the numerator. The 4 negative in front, so it goes in the denominator. 5 positive, as you can see out in front, so that 5 is going to go as a factor in the numerator. And the 6 has a negative in front, so it goes in the denominator. Now, as far as the simplifying down goes, we could say, well, 3 times 5 makes 15. 4 times 6 makes 24. These are both multiples of 3, so we can do a little bit of simplifying down inside there. So we can say 5 over 8. So common log of 5/8. All right, now let's look at one where we have multiples out in front. So when you have these multiples out in front, we're going to use the power rule to move this up into the exponent and attach it to everything that's on the inside of this logarithm. So the first step here would be rewrite this as log, common log of x squared, plus the common log of x plus 1 quantity raised to the third power. Okay, now that we've taken care of these multiples out in front, made them into exponents, now we can combine these two logs together. As you'll notice, these are both positive, right? Positive in front of this log, positive in front of this log. So that means they're both going to end up in the numerator, or we're just going to put them over 1. We don't have to indicate that, multiplied by 1, or the 1 in the denominator, I should say. So simply going to be multiplied together what's inside this log, multiplied by what's inside this log. All right, on the next one, we have a 1/2 hanging out in front. So let's first move any multiples from in front up to the exponent. We'll talk through this. So log of x minus log of y to the 1/2 power plus log of z to the third power. The exponent gets attached to everything that was on the inside of this logarithm. Same thing with the last one. Now let's put them together. Now as we put these together, I see that the x has a positive in front of this log. That's indicating to me that it's going to be in the numerator. The y to the 1/2 power, negative in front, so I'm going to put that in the denominator. Z to the third power in the last log, positive in front, that's going to go up in our numerator. Now there is one more bit of simplifying down that may make this look a little bit nicer, and that's that 1/2 as an exponent. A lot more times than not, we're going to see this written as a square root as opposed to the 1/2 as an exponent. So you may just rewrite it like that to give a nice final answer. All right, one more of these, looking at one that has a little bit more complicated stuff going on the inside, but very similar as far as the process goes. Numbers out in front. First thing you want to do is those multiples go as exponents attached to everything on the inside. Log base 2 of x squared, bringing that along, plus log base 2. And if you're okay with it from that previous one, if you have x minus 1 to the 1/2 power, we're going to replace that with a square root over all of this x minus 1 in just a second. minus log base 2. Now let's be careful about this. We have x plus 3 squared, but that's all supposed to be raised to the third power. As we move this 3 up to the exponent, attach it to everything that's on the inside here. We're going to clean that up in just a second as well. So log base 2 of x squared, just bring it along, plus log base 2. I'm going to replace this with the square root of x minus 1 minus log base 2. Now to combine this together, we have something raised to an exponent, and all of that's raised to another exponent. So to combine these exponents together, get a little bit cleaner answer, we're going to multiply those together. So we have x plus 3 from the inside of the parentheses. 2 times 3 is going to make 6 on the outside. All right, final step, we've got to combine everything together into a log base 2. So this is where I'm mostly concerned about sign out in front. Positive, the x squared goes in the numerator. Square root here, we have positive out in front. It goes up in the numerator as well. But on this last one, all of this has a negative out in front. That tells me the quantity x plus 3 raised to the 6th power goes in our denominator. And there we have it, as combined together as it's going to be. Hope this helps out as you're combining or condensing logarithmic expressions into a single logarithm. Good luck.